If your app has a like-dislike button but nothing uses it, you're wasting signal. We'll collect feedback, aggregate it, and plug it into evaluation so you know what to fix next. You might notice users tapping thumbs or leaving a star, but those taps never change the model. That is the symptom. The capability payoff is simple. Turn those small signals into a single, reliable metric you can monitor and act on. By the end, you will know how to normalize mixed feedback, find the worst runs, surface the worst examples, weight richer signals more, and date releases with a pass rate. I'm Professor Pi, teaching AI engineering and LLM systems from basics to advanced, with simple, concepts-first Python that helps you solve bigger, real-world problems. Online feedback loops matter because production apps are messy. Users give thumbs or stars at different times, with different meanings. The pipeline we need sits downstream of inference. It collects feedback, converts it to a common scale, aggregates by experiment run, and turns that into actionable triage lists and a headline metric for CI. Success looks like fewer blind deploys, faster issue discovery, and a dashboard metric that tracks real user satisfaction instead of synthetic benchmarks. Even 100 feedback events can tip you toward a clear fix. At its core, the idea is intuitive. You want a single number that means the same thing whether a user clicked thumbs up, thumbs down, or rated 5 stars. With that number, you can compare runs, pick out the worst examples, trust detailed ratings more, and decide if a change is safe to ship. The strength is speed and clarity. The weakness is signal bias. Thumbs are cheap and noisy. Stars are rarer but richer. We will make both useful. We will build a small sequence of helpers that do precisely that. First, we normalize raw feedback into a single 0 to 1 score. Then we average by run. Then we pull the worst items. Then we compute a weighted average that trusts stars more. And finally, we compute a pass rate against a target threshold. Each step is a short, inspectable snippet so you can plug it into your existing logging and dashboards. First, we normalize the raw feedback into numbers the pipeline can work with. This snippet converts thumbs and star ratings into a single 0 to 1 score. The list raw holds feedback events as pairs of kind and value. The small converter function 201 maps thumbs to 0 or 1 and stars to a fraction out of 5, unifying scales. The list comprehension scores applies the mapping to each event, producing normalized numbers. Finally, the code computes the simple mean average, which becomes a baseline quality metric for the session. The printed average shows the overall satisfaction level in a single comparable number. Next, we group those scores by experiment run to find which variant underperforms. This snippet aggregates normalized scores by model run and finds the worst run. The list runs labels each feedback event with a run ID, aligned positionally with scores. The dictionary avs computes an average per run by summing matched scores and dividing by the run's count. The min call selects the run with the lowest mean, indicating where users were least satisfied. The printed pair gives the underperforming run and its average, pointing you at which variant needs attention first. Now we pick the concrete examples to inspect and fix. This snippet regs feedback and surfaces the k lowest scoring cases. The variable k controls how many worst examples are selected. The sorted call orders indices by their score, so lower is more problematic, and slicing keeps only the bottom set. The join creates a compact summary mapping index to score, which you can use to fetch prompts and replies for inspection. Increasing K shows more failures, while decreasing it focuses on the most urgent ones. The printed list spotlights the exact items to audit next. Next, we bias the headline metric toward richer signals. This snippet computes a weighted average that trusts star ratings more than thumbs. The variable W star is a multiplier for confidence in stars, building a weights list aligned to raw. The weighted average WAVG multiplies each score by its weight and normalizes by the total weight, emphasizing richer signals. This makes the headline metric less sensitive to sparse thumbs and more driven by detailed ratings. Raising W star tilts the metric towards star-heavy items. Lowering it brings thumbs back into parity. The printed weighted average reflects a more reliable online metric. Finally, we translate scores into a pass-fail signal you can use in dashboards or CI. This snippet gates quality with a pass rate against a target threshold. The variable T defines the minimum acceptable score for a response to count as a pass. The list fails collects indices below the bar, useful for triaging into an evaluation queue. The pass rate PR is computed as passes over total, giving a crisp, comparable metric for dashboards and CI checks. Increasing T raises the bar and reduces the pass rate. Decreasing it relaxes acceptance. The printed pass rate is your go, no-go signal for deploying a change. You can map this toy flow directly into a real system by pairing each feedback event with the original prompt and reply in your logging. Use the worst indices to pull context and save those examples into a human review queue. For dashboards, publish the weighted average and the pass rate side by side so engineers see both trend and gate. Recap: what it is: a small pipeline that turns mixed thumbs and stars into unified, actionable metrics. When to use it: whenever your app collects lightweight feedback but you lack a clear production signal. One caveat: user feedback is biased and sparse, so treat the metric as a signal, not the final truth. Next step: tune the weight on star ratings, the W star parameter, and watch how the weighted average moves. This single knob often balances noise versus richness in your metric. If short, practical AI engineering helps, subscribe and watch the AI engineering videos.